Are you afraid of needles? Many people are. If so, you might find the article that we read today especially interesting. It is a science-related article, and the title is, "Can You Get Vaccinated Without a Needle?" This article was originally published in December of 2022. Paragraph 1. Vaccines are an important tool to help prevent the spread of infectious diseases like COVID-19. Despite their importance, it can be difficult to get such important medicine to everybody who needs it. We developed a painless vaccine patch that can make vaccines easier to transport. It could also increase access for everyone, especially those who are scared of needles. In this study, we wanted to determine if our vaccine patch could produce an immune response, increasing our body's protection. We measured the amount of antibodies produced by the immune systems in mice who received the vaccine patch and showed that this vaccine tool is just as effective as traditional needle vaccinations. We also found that the vaccine patch protected the mice from COVID-19 after a single application. These discoveries proved that the vaccine patch can be a safe and effective form of delivering vaccinations. Introduction. Have you ever been scared to get a shot at the doctor's office? We have developed a new method for delivering vaccinations that doesn't require a needle. Instead, a small patch with the vaccine on it can be placed on the skin. The patch is applied like a Band-Aid and doesn't require any special medical training, making it a more accessible option. Our high-density microarray patch has 5,000 small microprojections on it. The patch is like a piece of plastic with microscopic tips. The vaccine is sprayed onto these tips, and then the patch can be applied directly to your skin. One of the more important parts of developing a vaccine is making sure it is safe and that it helps your body prevent future infections. It does this by generating antibodies in your immune system. Antibodies are signals in your body that can protect your body from specific infections. The first vaccine was developed to fight smallpox in 1798. Since then, vaccines have helped to get rid of diseases such as smallpox and polio, saving millions of lives. Methods. First, we wanted to make sure the vaccine patch is stable at a range of temperatures. We tested the patch at 25 degrees Celsius and 40 degrees Celsius and measured the stability of the vaccine that was sprayed onto the microprojections. Next, we wanted to find out how effective our vaccine patch was compared to a traditional needle. We used 4 groups of mice. One group received the vaccine patch with the COVID-19 vaccine on it. The second group received a traditional needle vaccination. The third and fourth groups were control groups, receiving either a needle injection or patch that had no vaccine in it. We did this so that we could observe the effects of the first 2 groups and compare them to a group that received no vaccine. In order to measure how effective the different methods were, we used an ELISA test. This test measured the amount of antibodies that were being produced in each group. The ELISA test changes color depending on the amount of antibodies, showing the level of immune response that each method generated. More antibodies would mean a greater change in color, meaning the method was more effective. We also used a technique called virus neutralization assays. This showed that the vaccine produced antibodies that could prevent SARS-CoV-2 infection. Finally, we wanted to ensure the vaccine patch can protect mice from COVID-19 with just a single application. We gave the mice the vaccine patch and used the ELISA scan to measure the levels of antibodies. Results. Our experiments led to the following key results. Number 1, the vaccine patch provides a tool for delivering vaccines that is thermostable. This means it can withstand a wide range of temperatures while still being effective. 2, the vaccine patch resulted in more antibodies being produced when compared to traditional needle vaccines. This means that they can be at least as effective at delivering a vaccination. 3, mice that received a single dose of the vaccine patch were fully protected from COVID-19. These results tell us that the vaccine patch is a stable and effective method of delivering the COVID-19 vaccination. They are able to activate the immune system and protect the body from being infected. Discussion. In this study, we have shown that the vaccine patch is an effective platform for delivering vaccines. Using this system, any vaccine can be sprayed onto the microprojections of the patch and applied directly to the skin, just like putting on a Band-Aid. This makes it an important option in the global fight against disease. It is not possible to fully protect a population from a virus without a vaccine. The vaccine patch provides a platform for vaccinations that can be transported easily and delivered without special training. Its thermostability means that it does not require chilled storage, unlike some other forms of the COVID-19 vaccination. In a 2012 survey, it was found that up to 63% of children are afraid of needles. This fear can contribute to hesitation when it comes to getting vaccinations. The vaccine patch has been developed as a painless, easy alternative that will result in more people being protected from dangerous diseases. Conclusion. The possibility of getting a vaccination without having to have an injection sounds almost too good to be true, right? But the truth is closer than you might think. In this experiment, we only tested the vaccine patch using the COVID-19 vaccine, but this method can protect us from other diseases as well. Instead of going to the doctor's office for an injection, you might be able to get a patch from the local pharmacy and be good to go, protecting both you and your community. Well, I certainly hope that's a real possibility in the near future. I'm not afraid of needles, but I would certainly prefer the ease of a vaccine patch over having to receive a shot by means of a needle. All right, well, I hope you learned something and enjoyed the reading of this article, and I will see everyone soon in another video.